I think it's obvious that we have quite diversity here from IT and OT departments, even from telecommunication departments. There are some people here. Very good, very good. So then let's get started slowly. Thank you for your answers. Of course, today's session is mainly about our assessment report and what have we found. And before we jump into that, I would like to first remind you again the critical infrastructures and what are considered as critical infrastructures in my next slide. So there are transportation, manufacturing, government and administration, nutrition, health, water, finance, and municipal waste and disposal branches, which are also considered as critical infrastructure. But of course, there is one that is very important, which is the energy infrastructure, which spans diverse sources like natural gas, electricity, petroleum, coal, and renewables. And of course, the core mission is to produce and distribute the electricity. From extraction to transportation, every step matters. And of course, a reliable power grid is essential for delivering energy to the consumers, to our households, to the manufacturers, and so on. So, and these environments are usually in the responsibility of the power grid companies. I think looking at most of your job titles, you are more or less aware of that specific thing, but it's always good to mention that. So what did we do in general? So what is this security assessment across 100 power grids is about? So we have a sensor, it's called StationGuard sensor, and we installed these sensors across 200 to 300 substations and many power plants and control centers as well. It wasn't only substation level, of course. And most of the issues we found was more or less within the 30 minutes after we plugged the sensor into the location, into the network. And sensors were afterwards typically installed for 4 to 6 weeks to understand the posture and the infrastructure of the network that was installed for. And we also tried to understand, meantime, the board level commitment of the power grids on their perspective, how they are looking at the OT security. Are there any effort at all to improve the OT security in power plants, substations, control centers, which was also quite important, of course. So those were also under our radar. And then at the end of the day, our experts created a template, complete report, and delivered to our customers. So why did we do it is, of course, it also matters probably. They were regular project installations. So our customers had rolled out IDS system and they wanted to install and roll it out across their substations and multiple different other networks. We also received security consulting requests from our customers to conduct a security assessment. And at the same time, we wanted to identify the security posture of the critical infrastructure and address the issues with you in this webinar, in seminars, and so on and so on. So as you can see in these pictures, we have traveled more or less all around the world. In every continent, we had installations, and these studies contains results out of these installations, basically. And the deployment was done with an IDS, as I mentioned. So the IDS analyzed the network traffic and it can also detect the cyber attacks. And when it comes to how it processes the data or how it receives the data, we have used these two options, either a mirror port that is more or less available in every switch installed in the substations, and also like power plants and control centers, or sometimes we used the network tabs that allowed us to tap into the traffic. And at the end of the day, we had the visualized communication. The cyber risks in the network were also visual. We could have seen that based on our findings in StationGuard, and we also received an asset inventory, which is then also used for vulnerability management and also asset management. So, short before I switch into the findings, I would also like to inform you what the StationGuard solution is looking like. As you can see in here, we have sensors located in power plants, substations, and control centers, which correlates the data. And then all the issues is found in the sensor. And then we have a grid ops on the higher level, which is the central management system of the sensors. It provides detailed asset inventory on a central location and includes also the vulnerability management system. So, and while the StationGuard sensor is doing in-depth anomaly detection, active asset identification, as well as passive, and also does asset and network health monitoring, which we call functional monitoring. So before we went into these environments, we had to, of course, know what are the attack vectors, because you cannot protect yourself if you don't know the potential attack vectors, and therefore we first identify those attack vectors when we start this journey. So if you look at this architecture here, you could see a similar architecture also in your organization, where you have the IT environment on the left side with a lot of enterprise devices and networks with DMZs and remote VPN operators. And on the right side, you have the OT, where your power plants and the substations are. And in the middle, you have the control center, SCADA control center. This is more like a hybrid environment where both OT and the IT is involved. And this is where they come across together and start communicating, because most of the time, OT and IT doesn't communicate too much with each other since the responsibilities are different. Of course, the attack vectors arise from OT to IT level. In the IT level, you can see a lot of phishing and impersonating attack vectors that could be used, and also prohibited. There are attack vectors within the control center, SCADA control center, with prohibited switching commands, which we have seen in Ukraine in 2015. And on the OT side, we have the possibility of getting malicious malwares being put into the locations of the substations and the power plants, which was the case in 2010 with Stuxnet attack. So these are the attack vectors that we always have to consider before we even start doing some protection into these environments. And of course, if you go into the substation level or power plant level, the remote access, control center connection, engineering PC, which is being plugged into the network, testing PCs, test sets, even the setting files and the test documents can be used as an attack vector by the attackers to either gain crucial information or simply access into the power grid substations. Okay, so now we can, I think, start with the our findings, which why you're here for. But before that, we would like to place another question, which is, what brings you to today's webinar? I think it would be very nice for us to know your motivation, which would then help us to also formulate our next webinars. All right, so we have the first answers arriving. Curiosity, which always makes sense. Regulations, that is correct. Some organizations are driven by the regulations, basically. And we can see a lot of regulations coming through specifically for being prepared to an incident response in OT environment by doing monitoring. Challenges of the power grid, experiences of the other experts, getting something new, which always makes sense. Yeah. So let's delete a couple more and then carry on. latest trends, lessons learned, find new information, collecting knowledge, EU regulations, again, to learn about security and your products. All right, looks like we have a lot of answers and a lot of curious people. Looks good to me. Thank you very much for your answers. Most importantly, the knowledge improvements, of course. Great. Let's carry on then. So let's start with the organizational troubles. I think we are not going into the details for the organizational troubles. This will be a technical webinar, but it's still good to know what is happening in the higher level and what are the challenges over there. So I think one of the most important troubles or issues that we have seen on the higher level was that the organizations are not triggered to do anything about OT security, at least some of them, without a regulation. So they are regulation driven to apply the cybersecurity. Of course, this doesn't apply to everyone. Lack of manpower is another important point where we have seen it. So there are a lot of resource issues there in the organizations. Therefore, people are hesitant to take responsibilities, right? When you don't have so much team members, you also don't want to go after something new. That's why you take less initiatives, because you're already overloaded with your current workload. So cybersecurity risk assessment of the IT departments, because there is always a cybersecurity risk assessment or risk management process in the IT. It's not new for them, but they don't cover the OT area. This is mainly the case that we have seen. So there is an independent IT and OT security processes. That's what we have seen there. So lack of collaboration between IT and OT. And the SOC of the power grids has an IT-centric, so they only get the logs from the IT area, not from the OT. They don't prepare themselves for incident response scenarios because they don't know what is exactly happening. They don't have any logs coming from the OT locations. And also sometimes regulations prevents them getting logs from OT level because of the direction of the traffic and so on and so on. So these are more or less what we have seen as an organizational trouble, generically speaking, for some of the utilities across the world, which is, of course, important to touch on these topics. But most importantly, there are a lot of technical issues and also our findings in this area. So we have seen all these vulnerable devices, weak segmentation, external connections, unneeded services and protocols, surprise devices, configuration errors, and even time synchronization issues. And I will dive into the details of these now. So let's start with the vulnerable devices, right? This is it's a story that we are used to, I think, from these OT environments. But of course, just before switching to the next slide, maybe, there is a reason that people don't apply patches in the power grid or in any OT environment. And it usually looks like this. So would you do a firmware upgrade to airplane cabin pressure controller while the aircraft is flying? And this is more or less similar to what power grids are coming across. So this is what they're facing. They can't do patches because it might have a negative impact on the operations. So patching usually needs the energization of the power lines and the generators, and it requires testing. So you need resources, you need scheduling. Of course, there are ways to avoid de-energization, like having a replica environment as a lab in your IT level or in your office to apply those patches there, do the testing there, and see if everything works, and then apply the patch on the site. This could be, for example, one solution. But also, the new softwares might introduce new bugs. And this might be the problem as well for example, protection engineer. So patches might behave different on different hardware revisions. And also patches can have side effects on your custom program logics. Program logics are used in the protection, interlocking, also like in the process automation. And if those logics are changed or somehow gone because of the new update, you are in trouble. You need to test that everything works. This means times and the resources. So these two reasons are some of the reasons that Pipauget stuff doesn't apply patches in the OT networks. But how could you even identify your risk? How could you even detect the vulnerable devices before you even come to the level of applying patches, right? This is also an important question. So in order to get to know if you're affected by a vulnerability in the, which is published by the vendor, maybe, you need to know first you need to have an asset inventory. You need to know the vendor of your devices. You need to know the device type. You need to know the firmware version, and even sometimes you need to know the module in your device, the interface modules, for example, to understand if you have if you're infected by this vulnerability, or if you have if this vulnerability has any impact on your devices. So these are the information that you need to have in your hand. So here are some numbers for you. Just the top 3 protection and control manufacturer published this number of security advisories in year 2022 and 2023. And until today, 2,100 security advisories are published. And these security advisories contains more or less, sometimes even more, 3 security vulnerabilities, which affects from 10 to different type of devices. And it requires between 5 minutes and to 8 hours of an expert time to find out if you're affected or not. So you need to look at your asset inventory, you need to look at the vulnerability, and check if this vulnerability really applies or affects your devices. And this is almost a full-time job. So what we did with our solution in this case is basically our solution helps us to get this asset inventory through some passive and active ways. So automatic discovery from the network is one way that we collect the asset inventory. We can also use engineering files like SCD files, SQL files, CSV files, even the project files from different manufacturers to convert the data into a importable CSV format that will then reveal all the model, vendor, and hardware version information. And sometimes we could also do active device interrogation using MMS protocol under IEC 61850 standard to collect this asset inventory. We could also synchronize asset inventory with other systems, other asset management systems. So this is the first step for us to get to the level of understanding if we have vulnerabilities or not. So we have the asset inventory, and then we have a vulnerability database, which we constantly collect from different sources, manufacturers, and so on. And then we compare this vulnerability database information against the collected device type database information. And then everything that matches out of that algorithm we have will be then reviewed and automatically listed for the users. So all this effort that I just mentioned for a full-time employee can be done automatically with minimum effort spent on it. And that's basically how we get to know if there were vulnerable devices or not in these environments that we have tested. Weak segmentation is also what I mentioned, is something that we also have seen quite a lot. So we could see substations, multiple substations connected with each other without any security measures such as segmentation. And this kind of creates a wide attack surface for an attacker. So if I'm an attacker who find my way into the substation A, I could then also do something malicious in the substation B because I have an access to it. So we have also seen scenarios where the service LAN and the SCADA communication are on the same network, and it's always good to separate your service LAN where you configure your devices from the SCADA communication in order to avoid issues in the SCADA communication, because that's where your operation is running. Sometimes the high bandwidth, because of some file downloads, because of some configuration uploads, might jeopardize the availability of these networks due to high bandwidth usage. That's why it's always good to separate those, and also separation narrows down the attack surface for the attackers, right? So this would be the optimal way to apply segmentation, where you have firewalls, routers, this layered protection, right, in between different substations. But of course, this will not also protect you 100%, because there's no 100% protection in cybersecurity. Since humans are configuring these devices, there could be always some issues within these security layers. But of course, this is the minimum viable product, I would say. You want to have a security, which is the one in the bottom. All right, let's carry on. The external connections and the unauthorized accesses. This was also something that we have come across a lot, to be honest, which reveals then the configuration mistakes, which I will now point it out. As you know, most of the time, also probably in your organization, the operational networks are separated from the IT network with a lot of security layers in between, right? So you have secure limited access from Office IT to OT network. You have jump servers, DMZs in the middle, a lot of firewalls and routers. And from OT network, you have another layer of security you have to pass through with a lot of authentication and security implementations to finally access to your substation level. But even with this many security layers implemented, there were more connections than expected. So more connections from OT network or from Office IT, so layer 3, 3.5, layer 4, into the substation level. And this was mainly because of the configuration mistakes that has happened in the routers and the firewalls. So we could see a lot of IP addresses trying to communicate with HMI, for example, or with IEDs through various protocols. We could also see that for example, HMI web browser server DNS lookups were making its way all the way up to the Office IT and even reaching to the internet level. So due to these update servers, because of a configuration mistake in the router. So this has been a lot of time the case that we have seen. We have seen also like public IP addresses communicating around the substation, which was terrible, of course. And sometimes there were direct internet access left by the service provider, because they need to probably let someone remote in to solve some issues. I was a service provider in my previous career, and this was something that I have seen a lot of time. You need internet to troubleshoot the problem, but at the same time, your PC is connected to the substation station bus maybe during commissioning, which is quite often. So those were also some of the reasons that we had these issues. And I must say that the remote access, these external connections, possess the highest risk when we go back to the attack vectors. This is one of the most exploited attack vector that we keep seeing in the cyber attacks happening into the substation information systems. Okay, unneeded services and protocols. I think this is something that you would also agree with, right? We could have seen a lot of Windows file sharing, IPv6, RDP protocols left enabled in the devices. So no hardening was done into the Windows machines. I could recommend this website. There are guidelines available there on how to do Windows hardening. And this is something that should be written as a specification during commissioning of the substations to apply the hardening before going into the operation, into these devices. But mainly, most of the time, it wasn't. So you could see a lot of HMIs in station controllers with Sentinel SRM licensing programs installed, and also doing a lot of broadcasts. And some of these services are mostly active and mostly unused. So they are not used, but they are still there. And some of the services broadcast sensitive information. And this information can be read by an attacker, which is conducting a reconnaissance, listening the network, trying to understand who is there, what are the information, what is the IP address, what is the vendor, software version. Some of these informations are unfortunately broadcasted through some services. And if you don't turn them off, an attacker could get a lot of information out of that. So we always recommend to apply hardening during commissioning, also like afterwards as a part of security projects in our consulting services in Omicron. Yeah, so, and also it's also worth mentioning, there are some exploits and vulnerabilities. So some of the active protocols and services contain some vulnerabilities. For example, NetBIOS is one of them when it comes to the Windows protocols. And these NetBIOS vulnerabilities can be exploited by an attacker to gain access and information from Windows machines. So this is also like another reason why we want these services to be shut down. Okay. So, sorry. Carry on with the next one. The surprise devices. This was really interesting. We have seen a lot of unknown MAC and IP addresses in the substations, as well as in the power plants. So according to the documentation of the engineering team, they must have 130 devices, for example, in one of the substations. While we have come across 200 devices found in the network, where the maintenance team was not aware of. So this was more or less the case in every substation, especially in the ones which are conventional. So the ones that has been like commissioned, I don't know, 10 years or 15 years ago. And these IP addresses and MAC addresses, they're often unknown. But of course, our StationGuard could reveal the characteristic of these devices because we will keep monitoring the network. We could see what these devices are doing. Does it communicate through 104, TMP3, IC6150, or Modbus on TCP? So we could more or less figure out what these devices are there for. And some of these devices were dysfunctional. So there were no need for that device, but they simply forgot removing out of the network. So these surprise devices were a lot of the times the case that we have come across in these substation automation systems. Okay, let's see. The next is the configuration errors and the time synchronization issues. So we should always remember that these kind of OT environments are time-critical environments, and if there are such time synchronization issues, it needs to be known immediately. So the configuration changes are rarely done in a long-time operational power grid devices. We all know that. And when the configuration changes are done, it might be sometimes challenging to track it, right? Because you have contractors on site, you have third parties coming in and out, doing some configuration changes where, as a system operator, you're not aware of what's going on. And in terms of our implementations, StationGuard could immediately detect those configuration changes due to its capabilities. So And also, you need to keep in mind that those configuration changes might create issues for operation. Imagine if a service provider mistakenly reset a protection function. I did that by mistake. I did break the synchro check relay, for example, where we couldn't re-energize the substation for 3 more hours after the scheduled energization time. So this can happen, and because of that, you need to be able to monitor what's really going on and when is this happening. Sometimes there were also cases where the goose configuration was changed, and because of that, the interlocking was not working. And the system owner didn't know that because they haven't operated any circuit breaker or disconnector until then. And because of that, it's almost impossible to know unless you're not monitoring specific logical nodes in the 61850. Because once the interlocking is broken, the remote commands on these connectors and circuit breakers will not work, probably because the interlocking conditions are not fulfilled. So this was more or less the case in multiple substations that we have been in. Sometimes the engineers went out there and changed the configuration of the relays, and by mistake, they, for example, turned on RSTP configuration instead of the PRP in a PRP HSR network, which then broke down the PRP link, which was also detected by our solution immediately. So this kind of configuration changes might create the operational issues, and it is always good to be informed immediately by a monitoring system. Time synchronization issues, this is also important, right? We said it's a real-time operational environment, so protection engineers will know that probably, where the timestamp of the fault recorders is very important when it comes to doing protection incident analysis. So all those COM285 files that are created, right? So if an IED or a PLC has a broken time synchronization, you might not know when the event has happened precisely. That's why any time synchronization issue in the PLCs or in the IEDs must be detected immediately. And this is something that you can do it through the IC61850 goose messages. So the goose messages can reveal these time synchronization issues. And this is how our solution also picks this up and informs the system, informs the user about the time synchronization problems, which was more or less the case, at least with 1 or 2 IDs in every substation. So this is something that is also worth mentioning. And on the right side, this is the alarm that our solution has triggered, as you can see. Also probably worth mentioning, the StationGuard tracks the configuration changes through the congraph logical node, which is available in the IC61850. So we can import an SCL file into our solution and get the latest configuration revision information. And then we can compare that to the live traffic and understand the differences in between. And that's how the configuration changes are detected. All right, so the secure substations actually do exist. Maybe you are also working in some of them. So this is an installation in a greenfield substation. We also had a case study with them. They're also our customers. It's the Swiss Distribution and Generation Utility CKW. They have a very sophisticated security architecture where they applied multiple firewall zones on a station bus on a very low level when you consider it from the PUD side, like PUD level 1 or between 1 and 2. They have switch port security applied into their switches, so not every device with unknown MAC address can come and plug into the network. So if the attacker is inside already, they cannot simply go there and plug their laptop into the network because their MAC address will probably be not registered. They have role-based access control in order to operate some disconnectors and circuit breakers on an IED level. because SCADA level or base access control is anyway there. But on an ID level, this is also something that not every utility applies. They have data diodes to limit the direction of the traffic in certain areas that doesn't require bidirectional traffic. So they applied this defense in depth strategy, where they also implemented a StationGuard sensor, where they monitor what's going on. Because you can apply all these security measures and think like you are secured now, but you need to also keep monitoring to make sure that all these security measures work as expected, and if not, then you need a monitoring solution to be informed in case an attacker is breaching all these security barriers. So if you want to read the case study, please approach us. We will then deliver it to you. Coming back to the conclusion, of course, this was obvious that most of the target security posture revealed that how cybersecurity implementations in these OT environments were overlooked. So it wasn't considered at all under the cybersecurity risk management process. Of course, just before switching to the second bullet, we should also say this. Recently, there is a very high interest on the OT security implementations and the processes on the, for example, on the substations, on the power plants, control centers, for the power grids. So it's really picking up right now. And one of the main reasons is because of the regulations. There are a lot of regulations coming in every continent to which leads the power grid CISOs to apply security and consider security in the OT environments. So this is changing, but slowly, also worth mentioning. And IDS, which is tailor-made for OT networks, specifically for the power grids in this case, can quickly reveal the hidden OT network weaknesses. So the security assessments can be done within less than an hour. And that was more or less most of the time the case for us. As we installed the sensor for a month of time and sometimes left it there because it was a project. But the findings were already there in the first hour when we plugged in our mirror ports or taps into the network. So this, of course, is more or less related to how your system is familiar with the OT environment. If you take an IT IDS and put it into these networks, it won't work probably. But this is also important that you have a tailor-made IDS for these environments. And please, please, please keep an asset inventory so that you can manage your assets, because most of the time the asset inventory documents doesn't match the reality on the substations. And if you have an asset inventory, you can check your IAD or PLC vulnerabilities. And also important point, you need to segregate your station networks to narrow down the attack surface, which is quite important in terms of limiting the attacker's accesses. And finally, the IT-OT collaboration is essential for the cyber resilience in the power grid. And this was more or less the reason that we had seen cybersecurity being overlooked in the OT environment. There were a lot of times that we have seen IT doing their own security risk management covering OT. At the same time, OT has a parallel process to also do a cybersecurity risk management in the OT level, and they get to know, or they are informed about these processes through us when we are involved in the conversation with the both parties, which is of course not so well situation for the power grid people there. So that's why the collaboration is very important. I think with that, we are at the end of the webinar. Thank you for your participation. I wish you have a nice day wherever you are in the world, and hope to see you next time. Thanks.